name's Colby Harper. I'm the founder and CEO of Pathfinder Wireless. Pathfinder has led everywhere from quite tactical implementations to leap ahead strategic wireless innovation efforts, early and late stage R&D and operations since the 2G era. We're a founding member of some international standards R&D organizations and initiatives within them. Could be anything from the stand-up of the original organization, and this is as a collaborator and a participant with other industry peers, as well as maybe there's a specialized work group or task group or temporary effort that needs to get underway. And there's some uncertainty initially in getting that underway. Ecosystem uncertainty, it could be schedule or technology uncertainty associated with it. So in those uncertainties, and a number of stakeholders might be trying to achieve something, helping that move more quickly and reducing and managing the uncertainty and risk associated with those, so that whatever the outcomes sought are more likely to be attained. So we try to help there. It's quite a bit of strategic advisory role, though we do find that to make some of those strategies move forward and succeed, it's necessary to have a player coach type of relationship at times, right? So even the tactical components of the toolbox, right? Helping an organization develop their strategy plus their tactical toolbox to execute that strategy. That can have that can come in the form of anything from actual technology and product design collaboration, right? Just at certain points that augment whether it's a innovative startup or a Fortune 50 company or a government agency, to augment their efforts. And a lot of it is the workforce development, right? So to help our strategic, the initiatives that come from a strategic level to help them achieve their outcomes, right? A lot of that has to do with sometimes just real simple environment familiarization and workforce development, because the capabilities are usually quite strong in our partners. We've been lucky with that. So it's developing and honing and augmenting and helping them get farther faster to achieve whatever they are in particular looking for. And today, of course, we're focusing on spectrum, and that is a focus. Spectrum sharing, the technology and the regulatory environment context within that, and then the associated regulatory as well as technical standards efforts, helping the initiatives move through that always changing ecosystem is probably where we provide the most pointed advantage to our partners. A response to low latency applications needs. So sharing, we've made so much progress as an industry, and within more traditional high bandwidth mobile broadband type of communications applications, right? A little bit more the 4G type of application sharing has made a lot of progress. For instance, with CBRS, Pathfinder is one of the founding members and still a member of the steering group of CBRS, the 3.5 gigahertz effort with our DOE partners and with a tier one US operator. We created the initial SaaS architecture for WinForm, for the CBRS standard. And the key there is that someone had to do it, so we got together to kick that off. It became robust, though, through the collaborative efforts of all the parties, and many of the members of NSC as well, of course, were involved in that. But that's, and it is developing too. But when we're all aware of 5G now, and beyond 5G, 5G Advanced, and on our way almost too rapidly to 6G, low latency and critical communications really comes into play. And the control loops get so, they're becoming so fine that the time to make a decision and the time to execute that decision and implement the policy control points in the network for critical communications is both an advance in spectrum technology. There's a lot of R&D going on across the industry, particularly in the US, but across the industry, government, academic, and industrial R&D labs, right? So it's being treated, though coming together in finding frameworks, technical as well as regulatory, that can support that type of sharing is it's an opportunity that's being addressed, and it's a challenge, right? So low latency critical applications for IoT, for emergency services, for basically any info physical control applications, which is really where the value is in enterprise verticals, whether that's enterprise, again, a Fortune 50 or government as an enterprise, or startups that are trying to create innovative solutions to meet their various customer and market needs, right? That's a challenge. It's being worked through, but they're great advances. Taking those advances to workable industry standards, solutions that and frameworks and even lingo that is shared, that's a challenge. And then, of course, adopting and promulgating those specifications and standards into the marketplace for actual business and enterprise initiative value, that's probably a challenge associated with that. Another area that's an important advance that has those two same sides of the same coin, the 2D to 3D transition. It's something that whether it's your electrical engineer, your RF engineer, on up to the operator, on up to the R&D scientist working on theory, all the way to implementation of algorithms, right? Everybody knows this. We have our tool sets and our thinking to a great degree is in 2D. We know the vagaries of the wireless channel. Spectrum is subject to them. That's what we've been working towards for decades. So there's a lot of work, though, everybody's aware, but we're right in the middle of the tool sets, everything from the modeling and simulation to the actual protocols, and even frankly down to the component materials, the chips and the associated analog and digital components that go into the system for an advanced wireless communication system. Those are transitioning to a 3D awareness. We all know it's a challenge. And there are, again, great advances, particularly on the R&D side, even in the standard side. So those are advances that count today. They must be evolved, right? So pardon me, I may be getting into kind of some next phases, but it's two sides of the coin. We're right in the middle of that. Where we were is kind of where we are, and where we're going is making all of those more refined and more integrated. I would say there's one other area that's both an advance and a challenge that's worth calling out, and that is that for the different stakeholders and administrative domains that come into play with both spectrum technology as well as spectrum sharing, taking advantage of the advances in spectrum technology, say a large private operator, as well as a large public operator, they would like to share spectrum. They have operational characteristics of their networks, both from a forward planning perspective as well as day-to-day operations, that they have reasonable interests in sharing information, but not to the detriment of their operations and strategy. So sharing frameworks that allow selective information sharing that is still enough, that's still suitable for advanced and efficient and secure sharing to occur, is something that is an ongoing challenge. Of course, this also comes into play with critical communications, including government level uh, missions that, whether it's CONUS or OCONUS, that for everybody on the commercial side as well as on the federal side to come out ahead, the working out some of the kinks in that sharing has been identified. Lots of wonderful efforts, industry and government are underway now. Obviously, some of the key ones in NSC, and that's both an advance and again a challenge. Most. So mobile sharing. So where the infrastructure itself, and we'll use 5G as an example, though we try to be technology agnostic where we can in the spectrum regulatory and spectrum sharing realm, of course, and we need to because you've got various spectrum dependent systems from the communications aspect to the sensing aspect, imaging, et cetera, multiple users of the spectrum that need to coexist in one fashion or another. But mobile sharing, for instance, where the platform itself, in the case of 3GPP or Open RAN 5G, the G Node B, or components of the G Node B, when they, rather than being fixed terrestrially, are in motion, whether it's on a vehicle platform, terrestrially, cars, buses, trains, et cetera, or whether it's in the air. Anything from lower altitude UAVs to high altitude platforms to space. And wherever we draw the line, in particularly from a regulatory perspective, national regulatory authorities and internationally between space, it actually varies wherever you choose the Karman line to sit, affects which regulations apply and which international agreements apply. So, but mobility in that space with G Node B or components of a disaggregated G Node B is a critical area for R&D. There's lots of good work. It blends challenges, particularly when you're on an aerial platform, of the protocols and the underlying technology that will have fundamental architectural implications for 5G beyond 5G and 6G RAN. So that's a very important area. We're quite active in it. We did an early aerial platform, small form factor front haul between the pool of signal processing for the baseband and the remote units or radio units and antenna systems, the advanced antenna systems. Quite a few years ago now, partly standardized, partly pre-standardized with time-sensitive networking as an underlying synchronization challenges that come into play. Those, everything from the physical layer, the PHY, including PHY layer security, on up to the control systems at the high level, come into play and are subject to at least some level of change in mobile-based sharing. Right. Another area I would call out for awareness for your audience is very large scale combined with very high resolution cognitive simulation. That's a lot of words I'm throwing together there, but the idea is that you need a telescope and you need a microscope for great detail with very high resolution to understand what's going on under the hood with the actual energy over the air, as well as the technology that's emitting or receiving that energy. And also, though, it needs to be at a rather large scale. Usually you get either large scale and low resolution simulations or small scale, but extremely high resolution. To really answer so many of the sharing questions requires us to take off our kind of siloed hat and look at it comprehensively, because we're talking about spectrum sharing across dissimilar technologies. Even within the 3GPP family of radio access technologies, there's dissimilar sharing, right? Much less 3GPP versus other communications and other spectrum dependent systems. So the need in R&D and prototyping for simulations that have both extremely large scale and extremely high resolution. That's where we get to the truth, or closer to the truth. It's still not reality, but it's a better representation of reality, so that decisions can be made both from a policy perspective, the 18 months, 3-year, even 10-year time horizon, all the way down to extremely small time scales, in the sense that if you're doing dissimilar technology sharing, high resolution and large scale are key. If you have a region, say San Diego or Baltimore, Washington, right, the emergent, the mountains, the landscape of the types of interference for a given band. Imagine you're trying to, this is a little bit of a stretch, but imagine you're trying to fly through a very mountainous landscape, right? There's hills and valleys. Those are what's actually happening in the energy over the air in these regions. And the way those come about are greatly affected by very small changes in the actual operational networks, right? So to be somewhat proactive from a policy perspective and from a control, a scheduling and spectrum resource control and management and optimization perspective requires this combination of large scale and high resolution. The cognitive aspect of that is that, we have, particularly in the United States, but, in other regions as well, we have extremely advanced modeling and simulation capabilities. The industrial side, link and system level simulators, in the academic R&D base, as well as the government FFRDCs and other service labs, et cetera, right? There's great capability there in modeling and simulation. And there are good efforts already underway in cognitive simulation. By cognitive, I mean, I'm going to throw out a few buzzwords here, but artificial intelligence, machine learning enhanced simulation. We see it, and most of us as consumers hear a little bit about it, right? Or savvy consumers, right? In terms of autonomous cars, right? We're like, wow, these cars, different stakeholders in the ecosystem, they augment the learning that is necessary to get to higher levels of autonomy by simulation and appropriate models. What's changing, though, and some stakeholders are much farther along than others, and there are regional differences as well, is that in addition to applying different types of, we'll call it classical control approaches, as well as newer deep neural network reinforcement learning type of control approaches, really for the low latency regime, which is what we're talking about, the critical IoT applications, whether it's wide area control or whether it's control of a robot in a manufacturing plant that's operating next to a human, so that it operates in a way that is safe and does not harm the individuals that are right next to it, right? That's critical too. That criticality means that the low latency and determinism, right? So really rather rapid in terms of the time between the decision and the control event, as well as not just rapid, but it's not too soon and it's not too late in terms of the determinism. These all come down to the plumbing. And to really get that right at a large scale, as well as high resolution, comes back to things like not just we're going to take what we call a model-free deep neural network approach, but a combination of model-free and model-inspired approaches. By that, I mean, from a model, I'm talking specifically physics-inspired neural networking layers, right? So you've got all your layers of your control and your prediction and your pattern analysis, if you're trying to understand waveforms that are over the air, known and unknown, right? So there's a combination to meet low latency and critical communications needs within a spectrum sharing environment to have, for instance, emerging convex optimization layers. Convex optimization comes out of a little bit more traditional control regimes, though it is advancing on its own. But the combination of, for instance, a convex optimization layer with a physics-informed neural networking layer, with what still seems a little odd to me to call it traditional deep neural network layer, LSTMs, convolutional neural networks, right? There's different time and 2 and 3 dimensional aspects to the implementations of these different layers. We have a great interest in temporal CNNs as helping this low latency regime, but also we and others are finding that it's required to have a model-based approach for low latency as well. So physics model informed approaches as well. That's what really gets us interested kind of a little bit separately, and this affects the whole ecosystem. Just 2 things to call out today. To give an example of how all layers of the stack, down to the physical and chip layers and the materials layer, impact this. Gallium nitride impacts on the actual analog and then also the digital communications, right? The systems are getting redesigned, forward-looking systems are getting redesigned, not just taking the same approaches into the GAN, taking advantage of the GAN capabilities, but creating new and novel advantages based on the GAN capabilities. That's something that your audience may be interested in focusing on a bit more, because the state of the art is moving quickly there, as most of us know. And then this is certainly further out, but at some point, orbital angular momentum-based modulation is increasingly doable. Pathfinder had a collaboration, an R&D collaboration back in 2011 in OAM modulation. And certain things were a great challenge then that aren't anymore, right? So we expect to see quite a bit of more of the D side of R&D, as well as the prototyping than we saw in the past. It was really more research oriented, and it's moving into the D side, and fairly quickly from an innovation perspective into the, it will hit the standardization timeframes. It's open to win, but certainly somewhere in the beyond 5G, 6G era, OAM-based modulation will probably have some play, right? Because the technology environment is now able to address the challenges that were there, a decade ago. So I think those are things I would highlight for interesting R&D and prototypes today. So, well, as I noted, we're rather active in a number of fora, National Spectrum Consortium. We were, from its inception, we were happy and active participants in the Spectrum C2 and some of the standards subject matter experts groups. There's a lot of interesting work going on in the policy space and in the kind of international development space, whether it's from the Open RAN Policy Coalition, right? We're an active contributor to some of the sub-efforts there. In some international collaborations, like there was within the WIN Forum and within NSC, there recently kicked off a very interesting effort, both technologically from a spectrum sharing perspective, but also simply from collaboration of a multi-SDO collaboration that has some innovation there for spectrum sharing. It happens to be European and US, but it will be informed and has stakeholder voices coming from Japan and elsewhere as well. So that effort, joint effort between WIN Forum and NSC is promising, and I recommend those who are interested in spectrum sharing to take a look at how that develops. And a great interest to Pathfinder and myself is in taking some of the innovation that has traditionally been within a relatively small group of high capability and very innovative vendors and operators, and opening that up for enterprises, right? Who's not looking at that to take it for verticals, right? So that they can innovate knowing what they know. So the same thing that applies to verticals, commercial enterprise, as well as government enterprise, applying it to their specific needs applies, we think, greatly, and we're finding greatly also to countries that haven't been involved, whether in Latin America or even parts of Africa. We have had the opportunity to meet with operators and some regulators to, as well as some, often it's an academic side technology R&D rather than industrial R&D in some of these countries, right? But just like Fortune 50 verticals and others are looking to apply 5G and spectrum sharing technologies to their interests, innovation that is locally adapted to the needs as well as the often unique capabilities, whether it's agriculture or otherwise, in some of these countries, right? Things that are very important to them. They have local knowledge that can help adapt the innovation to their specific needs. This is everything from a smaller country in Latin America to a very large country that in like South Asia that has challenges on the rural and the digital FIDE type challenges, as well as contribute at the highest echelons to both standards and technology development, right? And I say that because then we can bring those types of learnings even back into the US, where we have right now on many folks' agenda are challenges in rural, not just rural end users and consumers, but rural industry sometimes has a challenge, whether it's mining or national forests, sensing, whether it's climate, right? These are wide area communications and wide area control issues, but they happen to overlap for the first time in history with technology capability and ecosystem development that can start to address both those that are below the digital divide and don't have to be, right? As well as the key stakeholders, and we'll call them anchor tenants in the wide area rural space, whether it's military or industrial and agricultural, et cetera. So that opportunity, I think, is really exciting because spectrum sharing is a whole different model out there, and in many ways much easier. Not easy, but easier. So that opportunity, I would like to take this interview with you to say we can do it. There's a lot of regulatory and technology work that's yet to be completed to make it happen and actually delivering value to all these stakeholders. But it's really a great opportunity. It's relative to the past, very inexpensive to do it today.